All right, today we're going to do 1.5, which is segment and angle bisectors. So let's talk about what a bisector actually is. So the midpoint, okay, that's going to be one of our definitions. So the midpoint of a segment is the point that divides or bisects. So there's your other definition. The segment into two congruent parts. Okay, so the midpoint is exactly what it sounds like. It's the point in the middle of the segment. It makes two equal parts on each side of it. So it divides it or bisects it. Bisecting is cutting the segment in half. Now, when you see congruent, remember congruent, you can also see it as an equal sign with a squiggle above it. So anytime that you see that equal sign with a squiggle, that means congruent. It means that they're the same. Okay, so that's the midpoint in a bisector. So when we have a segment bisector, instead of having just a midpoint, a segment bisector is a segment, ray, line, or plane that intersects the segment at the midpoint. Okay, now words sometimes are hard to picture what in the world we're talking about. So let me draw a picture for you. If we have a segment down here, we'll call this L, M, N. Okay, this right here would be the midpoint. M is our midpoint, so it means that LM is the same as MN. Okay, so if M is the midpoint, then LM is equal to MN, or vice versa. If LM equals MN, then M is a midpoint. Now if we have a segment bisector, that would mean we have our line here. We'll call it A, C, B. And I'm going to do a line for my bisector, which means it has arrows on it. So we have E, and let's do D. Okay, which means the line CD bisects the segment AB. Okay, so hopefully those pictures help you out a little bit. Let's look at an example. If, let's see, we have this segment, we're going to call this GHI. We're going to say this is 2x plus 1. The whole thing is 38. Okay, so if x, let's see, if h is a midpoint, I'm going to tell you that h is the midpoint. That information is always important. So if h is the midpoint, we're going to find x. So what does that mean? If h is the midpoint, it's right in the middle of the line segment. So if the whole line segment is 38, what would each part be? Well, 38 divided by 2 would be 19. And we know if h is a midpoint that these two pieces are exactly the same. That's why we could divide by 2. So we can set 2x plus 1 equal to 19. Never assume that h is a midpoint. You have to be told that h is a midpoint, or you have to be told that those are congruent. Now we're going to solve. So I'm going to get x by itself by subtracting 1 from each side. That cancels. We have 2x equals 18. Divide each side by 2. And x equals 9. If it asks you to find one of the actual lengths, you could plug it back in, or you could even plug it back in just to double check that GH comes out to be the same as the other side HI. Okay, so if we plug that back in, 2 times 9 is 18, 18 plus 1 is 19, we're good. Okay, I want you guys to write down this next one and then pause the video and complete it. So this is your example now. So the picture is going to be A, C to B, and you're going to have a lovely segment bisector here. We're going to call that E to D. I'm going to tell you that C is a midpoint. So if we have that information, and this is 12, and this is 4x, I want you to find what x equals. So go ahead and pause the video and complete that problem. All right, now what happens if that segment is on an xy coordinate? So if you go back to like algebra, remember how we could graph points on this xy coordinate. So if I have some kind of segment on the xy coordinate, I have a point A and a point B on here. Remember, to graph a point, we have an x and a y value. Well, I'm going to call it, since I have two of them, I'm going to call it one of them x1, y1, and the other one x2, y2 as my first point and second point. Doesn't matter which one your first one is, or which one your first one is, or which one your second one is, okay? Just label them, always label. So if we wanted to find our midpoint, when we're on a coordinate plane, we are allowed to count straight up or straight over. We cannot count diagonal because we'd be going diagonally across a box. We're going over, we're not going over one when we're counting diagonally. So to find the midpoint of a segment, you're going to add your x's together, so x1 plus x2, and divide by 2. It's kind of like averaging them. And then we're going to do the same with our y's. We have y1 plus y2, and then divide by 2. And when you simplify that, you're going to end up with an xy point for the midpoint. So let's practice some and see what happens. So for our first example, we're going to find the midpoint between M and P. So find the midpoint, I'm going to shorthand it, between M and P, okay? M is going to be at 2, 4. P is going to be at -1, 7. So my first step is always the label, label, okay? So we have x1, y1, x2, y2. I just label them in order. So here's my first point, here's my second point. And now we're going to plug it in. So my midpoint equals, I'm coming up here to my formula, x1, so 2, plus x2, which is -1, divided by 2, y1, which is 4, plus y2, which is 7, divided by 2. And then we're going to simplify. 2 plus -1 is 1. 4 plus 7 is 11. And you're welcome to just leave it like that. Make sure you put parentheses around it since it's an xy point. If you wanted to simplify down to decimals, you could do 0.5, and then 11 divided by 2 would be 5.5. Those would be the same answers. Okay? So I want you guys to try this next one. So you're going to find the midpoint. I'm going to write it over here. So find the midpoint, same directions, between A at 5, 9, and B at 7, 3. I highly recommend writing it out in the equation because that's where a lot of mistakes are made. So here's your example 2 that you're doing on your own. Go ahead and pause. All right, the next one. Now we're going to use that midpoint formula, except instead of finding the midpoint, we're actually going to find an end point. So we're going to find the end point that is missing. So find the end point given the midpoint and one end point. Okay? And for these two examples, I'm just going to tell you now that M is going to be the midpoint. It's not always, but for these two, it is going to be the midpoint. So I'm going to give you one point that is called C, which is at 3, 0. And then I'm going to give you the midpoint, M, at 3, 4. So be very careful with how you label these because this is not x1, y1, x2, y2. This one is our midpoint and an end point. So my midpoint, I'm just going to call XY because that's going to go where my MP normally is. Since our midpoint is an XY point, we're going to put that in replacement of MP. So here's our equation that we normally have. Y1 plus Y2 divided by 2. I'm only given one of the endpoints, so I'm going to call it X1 and Y1. So we're missing X2, Y2. So let's plug in what we do know. We know that the midpoint is 3, 4. We know that X1 is 3. And we know that Y1 is 0. And I'm not going to include that 2 because we don't need it. It's the only Y in the equation. Okay? So now I need to simplify. Well, we have to break up this equation. So this right here, remember this is an XY point. So I'm going to take this X and I'm going to set it equal to what this X would be. So 3 plus X divided by 2. And then I'm going to do the same for the Y. I'm going to take this Y that comes out to be my midpoint and set what my Y's are equal to. We'll do squiggle lines under that one. So 4 equals 0 plus Y divided by 2. And now we're going to simplify each one. So now we're going to solve. So to solve this one, 3 plus X is being divided by 2. So I'm going to multiply both sides by 2 to get 6 equals 3 plus X. And then I'm going to subtract 3 from each side to get X equals 3. So there's my X value. Now we're going to do the same thing for the Y. So since 0 plus Y is being divided by 2, I'm going to multiply by 2 to get 8 equals 0 plus Y. But what's 0 plus Y? 0 plus anything is that anything, so we just have Y equals 8. So my X is 3, my Y is 8, and there's your midpoint. Okay? If that didn't make sense, go ahead and re-watch it because the next example you're going to try on your own, it's going to be very similar to that. So let's write that next example down. The next example, you're going to find the endpoint. Given the other endpoint, whoops, oh my, the other endpoint and midpoint. Okay, so for this one, I'm going to tell you that D is 5, 2, and M is 7, 6. Remember, M is your midpoint for this example as well. Go ahead and pause the video and try that one on your own. All right, our next one is an angle bisector. That's our next term for today. So angle bisector. And it's very similar to what we have been doing, except now instead of cutting a segment in half, we're going to cut a bisector in half. So the official definition is a ray that divides an angle into two adjacent angles that are congruent. Okay, there's lots of definitions in there. So adjacent, what does that mean? Adjacent means neighbors. They're next to each other. They share a vertex and a side. I like to think of them as neighbors. And I seem to not be able to spell today. And then congruent, remember we have this lovely equal sign with a squiggle on top, just as a refresher. Okay, so what does this look like? If you want that picture so that these words make sense, let's draw this picture right here. We have an angle and then here's a ray in the middle. So let's call this angle A, C, B, and then we'll put this point D here. Okay, so CD is a ray, so I'm going to label it a ray. Bisects angle ACB. What does that mean? CD, this ray that's right here, is bisecting the angle, which means it's cutting it into two congruent pieces. Okay, there's your picture that explains that. If it's cutting it in two congruent pieces, you might see those congruent marks. You might see angle measures that are the same, or you might have a statement where it's angle ACD is congruent to angle DCB. All of that would mean the same, okay? So let's try one. If we draw this picture, so we're going to have this angle, and we're going to have a ray bisecting it, and we're going to say that this guy right here is x plus 40. Now when we label angles, it's normally going to have parentheses with the little degree symbol. That's just saying, hey, this is a degree measure for the angle. And down here is going to be 3x minus 20. Okay? So I'm telling you that this right here is a bisector. Remember, we can't assume that. So we'll call that AB. So AB is an angle bisector. Okay, that's important to know. So if that's an angle bisector, what does that say about each side of that angle? That means that if AB is a bisector, it's cutting it in half, which means this little guy is equal to this little guy. So we can set them equal. So we have x plus 40 equals 3x minus 20. And then we're going to solve. I'm going to get my x's on one side, so I'm going to subtract x over. That cancels this x. So we have 40 equals 2x minus 20. I'm going to get my numbers together, so I'm going to add 20 to both sides to get 60 equals 2x. Last step, divide by 2, and x equals 2. Whoops, x equals 30. Got ahead of myself. So there's x. That's if it asks you to solve for x. That does not mean that this is the angle. It does not mean that each of those angles is 30. To find the actual angle, we would have to take that angle and plug it in. So we would have 30 plus 40, which is 70 degrees. If we plugged it into the bottom, you should get the same thing. 3 times 30 minus 20. Well, 3 times 30 is 90, minus 20 is 70. So we're good. We did solve correctly. If it asked you for the entire angle, you would plug them in and either double them or add them together to get 140. So the biggest mistake people make is they don't pay attention to what the question's asking. It can either be asking for x, it could be asking for one of the smaller angles, or it could be asking for the whole angle put together. So make sure you know what the question's asking for. All right, so one more example for you guys to try on your own. I think this is example, I've lost track. This is example 4, I think. Okay, so example 4, if ray BD bisects angle ABC, find x. So here's your angle, A, B, C. Here's your ray, BD, and I'm going to tell you that this little guy here is x plus 15, and this one down here is 4x minus 45. Okay, go ahead and pause the video and solve that one.